Hi everyone, in this video I'm going to walk you through the steps of interpreting a pedigree and figuring out um, kind of what's happening. Is it dominant? Is it recessive? Who's affected? What would be the product when you cross certain individuals together? So hopefully this video kind of helps break that down. So the first thing that I want to note is these shapes. So remember that square is a male and a circle is a female. So first thing, draw a star beside an affected male. So remember that anything shaded in means that they're affected. Anything that's not shaded in means they're good. So this would be an affected male. Anywhere that you see a shaded in square is an affected male. So I'll put a star next to all of them just to kind of emphasize. But if it were to say an affected female, you would do all of these circles. Okay, and then the next one is define the inheritance pattern as either sex-linked or autosomal. When you're looking at this pedigree, you can start counting. I recommend counting up how many individuals are affected just in total. So count it up 1, 2, 3, 4, 5, 6, 7, 8, 9. You have 9 individuals who are affected. The next thing I like to do is break down how many individuals are male and how many are female. So I like to look at their sexes. So we have 1, 2, 3, 4 males, meaning we have 5 females. This step is kind of important when you're determining if it's sex-linked or autosomal. So in sex-linked, you will only see one sex being affected, where in autosomal, you see it's a pretty even split between the two sexes. So in this particular pedigree, because we have 9 total, 4 being males, 5 being females, almost a 50-50 split, we can say that this would be an autosomal trait. In one sentence, describe how you know the answer to part B. You could simply say, out of the 9 affected individuals, 4 males, it's almost a 50-50 split as 4 males are affected and 5 females are affected. But anything kind of explaining that and how you got your answer would work. Okay, and then we're going to look at the define the inheritance pattern as either dominant or recessive. So we're going to go back to the tree. A good way to look at this is dominant is going to show in every single generation with kids. So what I mean by that is this male right here is affected, this female is unaffected. If this was a dominant trait, you would have the children would then be shaded in, because dominant means it's dominant, it's being carried down, it's being shown in every single generation. In this case, you have the dad that's affected, the mom's not affected. Therefore, this has to be a recessive trait because none of these children here have it. They're all healthy, but then those children have children and they have kids who are affected. So like, for example, number 8 is unaffected and they married, their partner was unaffected, but then they had an affected child. So that's a good way of seeing it too. If you see any parents that don't have it, but then their children have it or a child has it, then you know it's recessive because it was masked in the previous generation. So here we're going to say it is recessive. And then again, in one sentence, describe how you know the answer to part D. I would use a specific example. So I would say in the second generation, so this is generation 1, 2, and 3. I would say in the second generation, person female 8 married an unaffected male. However, their child female 17, so I'm just using these numbers, female 17 was affected. Therefore, the trait must have been masked in the parent's generation right here, but was unmasked here for child number 17 in the third generation. So you can give a specific example. You can just talk about the pedigree broadly. Again, I usually like to use specific examples. So second generation, I usually say male and female. So female 8 was unaffected, and male 9 was unaffected. However, they had a child number 17 female that was affected. Okay. And then choose a letter to define a gene designation for the trait shown. You can choose any letter. I don't recommend letters that are similar to each other, like capital and lowercase are similar looking, so don't go with like, I don't know, W, U, V, anything that like only sizes the difference. So I usually like going with the letter A. That's just my personal preference. With A, I then like to write to myself that capital A would be dominant and lowercase a would be recessive. Okay, using your letter, fill in the genotypes of each individual in the pedigree. Pro tip, start with the ones you know, then work backwards to infer as many as you can. Okay, so a good trick that I like to start with when I'm doing this is going kind of back up to my tree and just like making notes to myself. So again, like I said, capital A is dominant, little a is recessive. Therefore, when we're talking about the specific genotypes, you would have a homozygous dominant, or you could have a heterozygous individual. They would both be unaffected. However, little a, this would be the one that's affected because this is a recessive trait. So again, little a would be affected, but these two would be unaffected. Okay, so now that we know that this is a recessive trait, so everyone who's colored in is affected, I like to start with those because I know that all of them have to have the recessive little a genotype because they're affected. And again, this is a recessive trait. Okay, so then once I start with those, I usually work my way from top to bottom. You can kind of do whatever you want. You can work left to right, whatever makes the most sense to you. So first thing I'm starting with is person number 1. They, a male who's affected, and they married someone who is not affected. So we're thinking this person has to have at least one big A because they're unaffected. Now we need to determine, do they have a little a or do they have a big A? In this case, you need to look at the children. So none of the children have it, so we can safely kind of assume that she is homozygous dominant and not heterozygous, because if you were to cross a heterozygous individual times a homozygous recessive, you would have that possibility of potentially having children with you'd have 50% chance of having children with that trait. And we don't, because none of these children have it. So it is safe then to assume she is homozygous dominant. So then because of that, because none of the children have it and it is a recessive trait, you can cross a homozygous dominant times a heterozygous individual, that's fine. But you would know that they would all be carriers because they have to get one big A from mom and one little a from dad. So they're all homozygous dominant. Heterozygous, excuse me. Okay, I'm going to move on down. So looking at the second generation here, we have an affected female and an unaffected male, and they have one child who's affected and one who is not. So you can assume that this child is big A, little a, because because this individual is little a, there's no possibility for her to get two big A's to be unaffected. So again, if you do big A times little a, here this 50% chance is their child number 13, and then their big A, little a is where you get kiddo number 14. But we know that she couldn't be big A, because the mom has no big A to give. Okay, I'm going to move to the other side of the tree. Again, I like to work top to bottom. So I'm going to move on to the right side. We have an unaffected male, but we have an affected female. So looks like they have they have one affected child, excuse me. Looks like they've married someone who had it. So they had one affected child and two unaffected children. So that means this individual has to have at least one big A because they are unaffected. However, they did have a child with the trait. So they would have to give a little a in order to produce the possibility of having an affected child. So dad would give that little a and mom would give one of her little a's, and that's how you would get kid number 10 being affected. So then we would assume that this individual, again, big A, little a, they would just be heterozygous or a carrier. Again, you can do the Punnett square if you want, but once you start kind of filling out pedigrees and practicing, you're going to start seeing like trends that you can start memorizing. So again, this is where kid number 10 would be the affected, and then number 9 and number 12 would be their unaffected kids being heterozygous. So that's how they got those. Okay, so you have almost everyone filled out. Now I'm going to go to my last two, which are number 8 and number 9. They're both unaffected, and we figured out that they were heterozygous individuals, and it looks like they have one affected child, number 17, and they have two unaffected children, 15 and 16. So really quickly, I'm going to cross them. So again, two heterozygous individuals. Do this. So heterozygous individual here and here. So I'm going to cross them. Okay, so as you can see, 17 would be right here. That's how they got their little a, or affected child. They had that 25% chance. However, because these two individuals, 15 and 16, are unaffected, we don't know if we know they have at least one big A because they're unaffected, but we don't know if that other A is a big A or if it's a little a. Because phenotypically speaking, they would both present as normal, because the dominant allele would be masking the trait. So in this instance, we just put a dash, because again, this is your 3-to-1 ratio, the phenotypic 3-to-1, where 3/4 of the products would be show the dominant trait, and 1/4 would show the recessive. So again, you don't know what it is. You don't know if they are homozygous dominant or heterozygous. So you just leave a dash and call it good. Okay. So next, she's asking if individual 19 had 4 children with an unaffected individual known to be a homozygous genotype. How many would you predict would have the same trait? Would have the trait? So number 19, let's go all the way over here. We have a, so homozygous recessive. So we are going to do a homozygous recessive, which again is number 19. And then we are going to cross it with an unaffected individual who has a homozygous genotype. Homozygous meaning same letter, so two of the same letter. So if they're unaffected, we would assume that they are big A, because again, homozygous dominant is what that individual would be called, and then we are going to cross them. Okay, and then here is where we would notice that all of the individuals here are heterozygous, so 100%, 4 out of 4, whatever you want to write, are unaffected, but they are all carriers. Because they all carry that little a, which is the recessive trait. Okay, and then we're going to look at letter I. If individual 19 had 4 children with an unaffected individual known to be a carrier for the trait. So another way to say carrier is heterozygous. What would you predict? How many would you predict would have the trait? So this, you would say, for the one previous, letter H, you would say 0 children, or 0 out of 4, whatever, 0%, whatever. None of them would have the trait. But in this one, known to be a carrier, so again, going back to number 19, who is homozygous recessive, little a, and they are pairing up with someone who is a carrier, so big A, little a, and then you would do oh my goodness, the cross for that. Okay, and then this would show you that 50% or half of them would be heterozygous or carriers, but this 50% would be affected. So when it says how many would you predict, you could say 2 out of 4 of the children, half of the children, 50% of the children, just whatever kind of ratio you'd like to use for that. But hopefully this helped kind of explain and walk you through how to figure out what is what with a pedigree. So if you want to stop, take a look at this. Here's my annotated copy. So again, recessive traits. I like to write them all at the top so I can help me figure out the family tree later. Affected male. Make this a little bit bigger. I know that's more than one sentence, but for explanation purposes, I did write a little bit more. Again, you can use specific examples. You can just kind of vaguely say first generation. I like to typically use specific generation and specific people numbers so they know exactly who you're referencing and they're kind of looking and grading the exams. But yeah, I hope this video helped. If you have any questions, let me know, and good luck.